This is problem 2 from the Chapter 4 closure packet. Solve these systems of equations using any method. So we know 3 strategies for solving systems of equations. One is equal values method, the next is substitution, and the last we learned was elimination. So I'm going to tell you which one I would do. You could do all 3 options on any of these problems, but one's going to be easier compared to the others. So part A, I have y equals 3x plus 7 and y equals negative 4x plus 21. They both equal y. Both equations are set equal to y. So since they're equaling the same value, that kind of tells me it's going to be the equal values method, which means I set this right side of the one equation equal to this part of the other equation. Since they both equal y, these two things should be equal as well. These are equal, these are equal. So 3x plus 7 equals negative 4x plus 21. So now I just solve this like a regular equation. I'm going to add 4x to undo the subtracting 4x. This right here makes 0. Okay. So 7x plus 7 equals 21. So then from there, I'm going to get rid of this positive 7 by subtracting it. That also becomes a 0 right here. Okay, so now it's just solving a regular equation. 21 minus 7 is 14. Divide both sides by 7. So I get x is worth 2. Now solving a system, you have to find x and y. So I'm not finished yet. I need to find a y. So I'm going to plug it back into either one of these equations. It doesn't matter which one. Pick whichever one that's easier. So I'm going to get rid of, or I'm going to plug it into this problem because there's no negative signs. So 3 times 2 instead of 3 times x, then plus 7. So 3 times 2 is 6, plus 7, that's going to give me y is worth 13. So you have x is 2 and y is 13 for the first one when we use the equal values method. So part B, we have another set of equations, a system of equations that are stacked on top of each other, but they're all like that. But this one's going to tell me I should do elimination here, because in elimination I want one of the variables to be the same number in front of the variable. So this is not the same number, but this is the same amount of y's here. There's 1y and there's a negative 1y. So when they're both opposite symbols, if I add them together, those are going to go away. That makes 0, right? Just like we did over here, positive 7 and negative 7, I have positive y and negative y. Those go away. So I need to add everything. So 3x plus negative x gives me 2x. That is gone. The y's are gone, and this 17 plus negative 7 gives me positive 10. Okay, from here, super simple, and divide by 2. X equals 5. Again, I'm not done yet. I need to find y. So let's plug it in. Plug it in the first equation here. So 3 times 5 instead of times x minus y equals 17. So I have 3 times 5, this is 15, minus y equals 17. Just copy it all down. To move this 15, I need to subtract it. I do the opposite. It's a positive 15, so I need to subtract it and make it go away. I need to copy everything else down. So make sure you copy down this minus or this negative sign. That's very important. That's a lot of people forget this when you copy it down. And then 17 minus 15 gives me a 2. Okay? So negative y equals 2. I don't want that. I want regular y, positive y. So I can think about this as negative 1y instead of just a negative sign in front. So let's divide by negative 1. So y equals, oops, that's supposed to be a 1 right there. So 2 divided by negative 1 gives me negative 2. So now I have 2 solutions, an x and a y, for that part B system of equations. And we did elimination there. Okay, part C, last one, we're going to use substitution. Not that I had to use one of each, but it kind of works out that way. So notice the first equation is already solved for one of the variables. The second one is not. That tells me I should probably use substitution. So this quantity right here, 3y minus 5, is equal to x. So in my big equation here, I'm going to replace x with this big quantity here, 3y minus 5. Okay, so instead of 2 times x, it's 2 times this stuff. So let me write that down. 2 times 3y minus 5. Then I need to copy everything else from the big equation. The only thing that changed was this. The 2 and everything else here stays the same. So plus 12y equals negative 4. All right, then I need to distribute this 2 to everything on the inside of the parentheses. 2 times 3y. 2 times minus 5 gives me minus 10. Copy everything else. All right, now I need to combine my like terms on the left side. I have a 6y, and I have plus 12y. That gives me 18y. Minus 10 equals minus 4. All right, so I just combine my like terms on the left side. From here, this is going to be my y. All the y's are on this side already, so I need to get rid of this minus 10. So to undo that, I add 10 to both sides. I have 18y, this part goes away, equals positive 6. You get rid of this 18 here, just like you always seem to do at the last step. You're going to divide. Divide by 18, everything except the y. So I have y equals 1/3. Okay, now that's a fraction, but that might happen. Might not always be a pretty number. So y is 1/3. Now I need to plug this back in. Let's plug it into this first equation because that looks a little easier since I'm trying to find x. So x equals 3 times our y value minus 5. Okay, x equals this 3 times 1/3 is going to give me positive 1 minus 5. So x equals negative 4. Okay, so notice for all 3 problems, we got 2 solutions. We got the x and the y. So always when you're solving a system, you need to have an x and a y, unless you get no solution or all real numbers, because then everything works or nothing works. But otherwise, you should always have an x and a y for your answer.